All right, everybody, welcome to the video here for lesson number 15, where we finally figure out what we have to do with that remainder. So there was a couple different methods here that we learned that were kind of new for dividing polynomials. So the first one was what we called the method of inspection. So for number one, this kind of reviews the concept of the method of inspection. If you're really not kind of good at it, or you're not good with mental math, you could totally go through and use a different method for any of these problems. But if you like inspection, you'll notice it does make things a little bit quicker. So for number one, this is a regular just factor and reduced problem. So if I factor, I get x minus 7, x plus 2, and the denominator stays just x plus 2. The x plus 2's eliminate, and we're left with x minus 7, no remainder. Now if you notice, the second fraction is set up almost identical, but the only difference is there's a plus 2 instead of a minus 14 there. So to make it so that they would be the same, I would have to subtract 16. I don't know what happened there. I would have to subtract 16 and add 16. Notice I'm adding nothing to the problem. But I'm setting it up so that I can make the first fraction x squared minus 5x minus 14 all over x plus 2, which we already know what it reduces to, plus 16 over x plus 2. So because we've already done that first fraction and we know that it came out to be x minus 7, I then can just reduce the rest of it, and there's your answer. For number two, if we factor that, we know that it's difference or sum of two cubes. So since it's a sum of two cubes, we can go through and factor that, I'm hoping, at this point. So we see x plus 1, and we reduce that away. So our answer here is x squared minus x plus 1. The hope with this method of inspection is to try and get you to be really good at factoring. Because the better you are factoring, to be honest with you, the better you'll be at your math classes for the next couple years. So for the next one, I noticed that it doesn't have the plus 1, so I'm just going to add 1 and subtract 1. Again, notice I'm adding nothing. I'm just kind of adding 0. So that's going to allow me to make two fractions, x cubed plus 1 over x plus 1, which we already know reduces, minus 1 over x plus 1. Because I already know what the first fraction reduces to, I can rewrite it as x squared minus x plus 1 minus the remainder of 1 over x plus 1. Number 3 asks us to find the quotient using synthetic division. So I'm going to put 1 in jail. I have a 1, a negative 9, a 5, and a 2. The 1 comes down. So I have 1 times 1, which is just 1, negative 8. So that's going to become negative 8 again, negative 3, and negative 1. So we're doing the same exact process. We just have to remember this is a remainder. It's not part of my answer. So my answer is going to be x squared minus 8x minus 3 minus 1 over the divisor, which was x minus 1. I like to put parentheses around that first part of the polynomial answer, so I see it's clearly separate from the remainder. Your choice, however you want to do it. That one wasn't too bad. Number 4 asks us to do this with long division. Now I know if this problem was on like a test or a quiz and it didn't specifically say long division, we'd probably all do synthetic division here. And to be honest with you, if it did say long division, you could still do synthetic division to see what the answer is and make sure your long division was right. But let's practice this long division skill because, like I said in class, there's definitely going to be some problems where long division is necessary. So let's do that. I see x squared goes first, so I have x cubed plus 5x squared. These cancel, this becomes a minus, so we have negative 3x squared plus 8x. So I'll put in a negative 3x to make that first term cancel. These cancel, this becomes a plus, so that's going to give me 23x plus 1. I would put a 23 in there, so I'd have 23x plus 115. These cancel, this becomes a minus, and we're left with negative 114. So our answer to this problem is just going to be x squared minus 3x plus 23, and we're going to have a remainder there of a minus 114 over x plus 5. Now, say you don't like that negative 114. You think you did something wrong because you got such a big number. Remember, you could just go through and do a quick synthetic division here. right? Synthetic division is definitely the more quick and efficient way of doing this. So the 1 comes down, we get a -5, that's a -3, that's a 15. 8 times 15, that's 120. Never mind, I'm being crazy. That just adds to 23. I don't know why I multiplied there. Trying to go fast for you. So 8 plus 15 is going to add up to a 23. So I have a 23 there, and then we have that -115, leaving us with -114. So we notice the remainders match, right? Next one, find the division of these two polynomials. Let f of x equal the first part, or the numerator of the fraction, and explain what f of 2 really means. So if we divide these, it doesn't specify, so I'm going to go with synthetic division. Again, it's just easier. Don't forget about the 0. Remember, there's 0x squared there. We have 2 and 11. If you forget about the 0, something weird happens. You'll see if you want to check that out. It doesn't work. Okay. So then we have 12 and we have 23. So our answer here is x squared plus 2x plus 6, and we have a remainder of 23 over x minus 2. Now the second part says to evaluate f of 2, which means I want to plug in 2 for x. So I'm going to have f of 2 is equal to 2 to the third power plus 2 times 2 plus 11. And we'll be working a lot more with functions and all the different things that happens with them over the next few units. And one of the big concepts that we're actually going to learn tomorrow is, what do you notice? When I plug in 2, I get 23, but 23 was the remainder. 2 is what we get when we solve, or is the 0 when that's a factor. So essentially, one of the things that we're going to notice in tomorrow's lesson is the factors generate zeros, and those zeros, when plugged into the function, well, they just so happen to generate the remainders. And one of the things that we learned in a previous lesson was that remainders, well, guess what? They tell you whether or not a factor is a 0 by plugging in the number. So there's a lot of things that we're going to kind of bring together in tomorrow's lesson. Let's see if the same thing happens here. So divide by x minus 1, so I'll put 1 in the box. 1, 2, 2, -5, no missing terms, so we don't have to worry about the zeros. So we have a 1, a 3, a 3, a 5, a 5, and a 0. We see a remainder of nothing, so that tells us the answer here is just x squared x squared plus 3x plus 5, no remainder. Now in previous lessons, that told us that x minus 1 is a factor of p of x. And we use that information to find the other factors. Remember, we could divide it out so that we could try and factor this expression, which isn't factorable, and we can find our factors through that method. It then says find p of 1. So if I find p of 1, I'm just going to plug in 1 everywhere I see x. So I can see 1 cubed plus 2 times 1 squared plus 2 times 1 minus 5. I don't know why I went on an arc there. So I have p of 1 is equal to 0. Notice, again, the factor comes from this. The remainder matches the value when we evaluate. Again, this is leading us to the next lesson. Number 7 says, knowing that x minus 3 is a factor of p of x, factor it into the product of 3 linear factors. You can do this 2 ways. You can do this algebraically, which I'm going to show you how to do, or you could do it graphically. You could graph p of x and see what the zeros are and work backwards to factors. Okay, so let's do it algebraically. So if I plug in and make the box number 3, no missing terms, so no zeros. The 1 comes down, we have a 3, we have -8, we have -24, we have -20, and we have -60. That's good for us because that means there is a remainder of 0. So that means right now, p of x has 2 factors. The linear factor x minus 3, which they gave me, and the quadratic factor that I just found out about by dividing. That quadratic factor is still factorable. So because that quadratic factor is still factorable, what we're going to say is, well, what multiplies to make negative 20, but adds to make negative 8? Well, that just so happens to be negative 10 and positive 2. Now, if you were to graph this in your graphing calculator, you're going to see a function. It's going to be cubic, and it's going to intersect at negative 2, 3, and 10, and it's going to come up and look something like this. Those 3 zeros could help you find the 3 factors if you really wanted to go that route. Sorry, I'm sure you hear my dishwasher in the background. I apologize. Next one says describe the end behavior of the function. Well, if you graph it, you're going to notice it's going to look like this, and do something in the middle, and then do that at the end. I know that already because of the first term, right? So the end behavior is going to start down and end up. So we're going to say as x approaches negative infinity, the function approaches negative infinity. As x approaches positive infinity, the function approaches positive infinity. That's something for sure you're going to need to know for your test. Then to determine if it's even, odd, or neither, we could either look at the graph and see if it's symmetrical or not, right? Even functions, remember, have line symmetry with the y-axis. Odd functions are the same upside down, aka point symmetry. Neither functions are ones that have neither of those two types of symmetry. But I'm more concerned about the algebraic method. So let's do this algebraically. So if I plug in negative x, that's how we determine if something is odd, even, or neither. So we do this quick algebraic step. I then have f of negative x, and then I'll notice that anything to an odd exponent changes the sign of whatever it's attached to, so it's going to become negative 4x to the 7th minus 3x to the 5th minus x. This function is not the same as the original, therefore it's not even. But it is the additive inverse. If you look, all the terms have opposite signs. So I can say f of x is odd because f of negative x is equal to negative f of x, the additive inverse. That's the answer I want you to see, right? That's something you should have memorized. You're not making that up, okay? Number 9 says to factor completely. 4 terms automatically for me tells me let's break this up into sets of 2. So I see z squared is the GCF, leave me with z minus 2. I see a negative 1 and a z minus 2. Right? I could have pulled out or divided out a positive one there, but then my terms would not matter. Right? So then I'm left with that z minus 2 and a z squared minus 1. Notice I put little slashes through my z's because sometimes they look like 2s. So if your 2's don't look like 2's or your z's look like 2's, you might want to do that. You'll see z a lot in this class. So then if we go through and continue factoring here, we see that the first term doesn't change. The second term is factorable. So the first term stays the same, z minus 2. The second term is just difference of 2 squares, z plus 1, z minus 1. Number 10 asks us to sketch this without a calculator. So see, do you know your rules, right? So let's talk about the function. So here's your x and y axis. We'll call it x and g since there is no y in this problem. I know the zeros are x equals negative 2 with a multiplicity of 2, 4 with a multiplicity of 3. So I have a negative 2 and I have a 4. Even multiplicities are going to be tangent or just touch the x-axis. Odd multiplicities are going to pass through. But before I can do any of that, I need to figure out what the end behavior is. So I know from this first parenthesis, I'm going to get an x squared. From the second one, I'm going to get an x to the third. Meaning my first term, without having to do all the multiplication, is just x to the 5th power. Meaning I'm going to start by going down. So g is going down at the beginning of the function. And as I get bigger, the function is going to get bigger because it's an odd degree polynomial. Meaning I'm starting down here. I'm coming up and just touching negative 2 because it's even multiplicity. It's going to pass through somewhere on the y-axis, and it's going to pass through the x-axis at 4. Now, if I want to know the ending, not the end behavior, sorry, the x-intercepts, I get those right from the factors, but if I want to know the y-intercepts, well, I'm figuring out what's the last term going to be. So for that first parenthesis, that last term is going to be a 4. For the second parenthesis, that's going to be 4 to the third power. It's negative, so it's going to stay negative. And 4 to the third power is 64. So if I multiply those two things together, I get, let me just calculate that really quickly because it's late and mental math sometimes doesn't work. Negative 256. I should have known that. So then we have negative 256 is where this graph crosses on the y-axis. So I have my end behavior, I have my zeros, I have my function, I know what it looks like, I even know where the y-intercept is. There's a ton of stuff that I can do here to find this out. Now, another way you can find the y-intercept is by plugging in 0 for x. If you do that, those are the two numbers you're going to get for the two parentheses, which is why we're getting them. Okay. Now, luckily for you, I'm never going to ask you to do this without a calculator, but it is nice to know the rules in case this was like x plus b squared and x minus a cubed. You should really know what that graph looks like, right? So knowing the rules is important. Other than that, that's your homework assignment. Hopefully this video helped. Sorry it's so late when I submitted it, so if you didn't get a chance to watch it the night before, hopefully you can watch it the next day. If you're liking the videos, you should probably subscribe to my channel so you know when I do post them in case I do things crazy like this and post them late at night. Good luck with your homework and start studying for that test. It's coming up quicker than you think.